Hello guys, welcome to the Genius Academy. So we are the training providers who wants to build their career in IT in the various domains like IoT, Linux, device drivers, embedded Linux, data science, machine learning, and artificial intelligence. So today we are here to discuss the next session on Linux system programming. So without wasting any time, let's get started. So today we are here to discuss about the file management in Linux. So what is actually a file management? What is file system? How many files that Linux supports? What are the different blocks when we will install the Linux? What are the links between the files if we are communicating between two or more processes and all. So there'll be much more that, and we'll try to write some code application so for better understanding. So let's get started. Actually, a system is an organized collection of the regular files and the directory files. So, what are the regular files like your .c files and all, your header files and all, your directory files like where all your files, .c programs are present and all. So, your directories are there. So, file system is created using a mkfs command. So, you can create your file system using mkfs, and when you install Linux, whenever or wherever you have installed, the hard disk is divided into 4 blocks, and that 4 blocks will be your boot block, super block, inode block, and the data block. So boot block is basically it stores the boot related information, and that super block will give you the information about the file system, including the size of inode table and the logical block. And the inode block will give you the information about the file related informations like a inode table. So and the data block is the the great majority of the space is used for the blocks of data that for files and the directory reading in the file system. So whatever the data storage will be there, it's the information will be stored in the data block. So how many files that Linux supports? There'll be a regular file, directory file, character special file, pipe file, link file, block special file, and the socket file. So when you come across about that communication between the sockets, either it's like TCP or UDP and all. So you may have think about the sockets and all. So how you are communicating through the sockets. So in that the socket file come into the picture. And if you want to communicate in the blocks and also suppose like a USB device drivers or any block related stuff, so then at that time block special file in Linux comes into the picture. So you have like I have also explained the earlier videos like how we can create the pipe and all. So in that pipe file will come into the picture, and there'll be a link file also, character special file, regular file, and the directory file is also there. So this is the basic of that file management. So in files how we can play around, we'll see that with the help of some coding and all. So we'll try to write some codes and all. So before that I just want to show you like what are the file access permissions are there. So how we can come to know that what are the access permission of a particular file. So that will be known by the chmod. So chmod is the command which is used to change the system. Like there'll be some file, so you have the read permissions, or there'll be some write permission. If you want to change the permissions and all, that access permissions and all, so you can change using the chmod. So first of all, like if you come across this hyphen rwxr user and hyphen xr, it's a group, hyphen x is the other. So this is the type of file. So when you are working in the Linux system programming or in Linux, so in the terminal you may have pressed this ls hyphen l and all. So you come across about this thing. So if you don't know this will just show you. Okay, I'm into my terminal. We'll just go to our directory, Linux system programming. Yep. So I'll just create some directory over here. um, File management, it's great. So now I'll just create some file data. I just written some character over here. Okay, so ls hyphen l. So you can see here, this will be the type of the file. Great. And this will be your username, this will be your group name, this is the time, the date, and the key file name data. So now suppose like you want to change the permissions of this particular file. So we'll just see that hyphen rw. Okay, this is the user. Okay, so we can change by using user hyphen r data. So if we'll see by using hyphen l, ls hyphen l, you can see here that read permission is not there. So now we will not enter into this data file. Okay, so let's see, permission denied. Chmod u plus r data. So if we can see here, the read permission comes into the picture. So you can use this, use u minus r, u plus r, or if you want to change the permission of the group, if you want to change the permissions for others and all. So as you can see here, this is the type of the file. So whatever based on your requirement, you can change the file system, that permission of that file. Okay, so what is umask? When you create a file manager check the umask that will give the permission to the file. We can also change the umask value by writing umask, like what are the permissions you want to give. Okay, so ls-l will give you the list of format, ls-li for display the inode number. So I have used ls-l. So if I'll use ls-li, so as you can see here, this will be your inode number. Okay, ls-ls to know how many blocks is there. Like file occurs at least 4 blocks. That will be approximate 4096 bytes. If you increase by 1 byte also, it will change the 4 blocks to the 8 block. So if you can try it out in your system, like how you, by writing this some file and just writing the 4096 bytes over there, and you just increase that 1 character byte over there, and you can just see that how many blocks are there, and you can come to know that it is increasing by 4 block to 8 block. Okay, so now next, what is link file? Actually, to know the links between the files, we have to go through this link file. There are two types of link file, which is like which are hard link and the soft link. What is actually a hard link? In hard link, change in one file will affect in the another file too. Inode number will be the same in hard file. Link count increases, like whenever you are incrementing some data into this original file, whatever the link to that other file, that count will increase. So if we are deleting any file in the hard file, like in the hard link and all, the another file will always be present. So we will demonstrate like what is hard link and how we can see that. Okay, so I have data file. So now the important note you need to take care that in any in the hard link as well as in the soft link, you have to take care that destination file is not present, otherwise it will give an error. Okay, suppose I have some data one file. Okay, so I just need to link these file. It's a hard link I need to do. I need to use ln command data and the data one. So see, fail to create the hard link. The data one means the destination file is exist over there. So you need to be very careful that your data like destination file will be not there. Okay, so now if I'll execute this, yeah, see, so now to check it's a hard link file or not, so you can see here this inode number will be same. Okay, so in this way you can link those files, and you can see like these are the like hard link file or not. Okay, so what is other one? Soft link. When we create a soft link, another file is created as a pointer. Okay, point to the original file. Okay, so if we are deleting the original file in the soft link, another file cannot execute. And how we can create this soft link? Just suppose, okay, so I'll just create some file one. So how can I create the soft link? ln-s. You need to be very careful that the destination file is not present here. File 2. Okay, so if we can see here, just see the file 2, the destination file is the pointer pointing to the original file, in which we'll come to know that this is the soft link. Okay, so in this way, from the terminal you can see like what are the files are hard link files and what are the files are soft link, like what are the link between these files and all. Okay, so stat. We'll come later into that. Like I'll just what I will do. I'll just write some program over there, and we'll just try to check what is actually the link between those files. We have just checked through this by using the for like ls-li. We have used list of formats and all these things. By checking ls-li, if that inode number is same, so we have checked that this is a hard link, and we have checked also that it's a that another destination file is pointing to the original file, and we came to know that it's a soft link file. So how we will come to know by using a call. Okay, so system call. The system call which we will use is a stat. Stat is a system call which will give you the information about the file. For example, if you want to know about the size of the file without opening that file. Okay, a few things you need to take care, so we will just see it later. So what I will do now, I'll just create one file over here. I'll just write some program here just to see like what will be the like what is the size of that particular file, what is it I know number of that particular file and all. Okay, by using stat system call. Okay, so now I don't have header file, so what I will do here, I have header file here. Yeah, copy this header file into my file management directory. Yeah, vi size stat dot c. So I'm using the header file hash include header dot h. int main. I'll just use the command line argument. At the runtime, I'll give the file name. So I need to use the argument over here, int argc, character, double pointer, argv. This looks nice to me. Yeah. So now what I need to do, if argc is not equals to 2, I need to pass the file name here. I'll just print that log message. I just print size file name. And we will return from here. Okay, so this looks nice to me. Yep. So now I'll just create the variable for stat. So if you will go through this system call, so there is like stat. Okay, we'll give you the file state. There'll be stat, there'll be a fstat, there'll be a lstat. So what is the difference between all these calls? Stat will give you that file related information. Fstat will give you that information about the file, but what you need to retrieve from this file descriptor. So you can't give that path name and all. So what you need to give here is fd. Okay, so lstat will give you that information about that destination file. Okay, so the header file you can use here is sys/types.h, sys/stat.h, and the uni std.h. So this is the structure of stat. So in which what you can see, like without opening that file, you can came to know that what is that INO number of that particular file, what is that protection, what is the mode of that. So is it a link file, it's a directory file, or it's a regular file. So by using this st underscore mode, you can see. I'll just try, like if we'll have some time, like I'll just write some program to give you the information. The particular code will give you the information about that a particular file is a regular file or directory file or a link file. Okay, so you can see that the user ID of the owner, group ID of the owner, and many more. Like you can see the size and the block size and the like how many blocks are allocated over there. So some extra things is also there. As you can see here, there are some macros are there. So these macros we can also use to check about the particular file. The particular file is a socket file, or is there any symbolic link between this files and all. That particular file is a regular file, it's a directory file or character device, or a FIFO file, or a block device. So you can use this macro in your program to check about the information about particular file. Okay, so as you can see here, so you need to go through this man page, like you will have that understanding about that file system. So what are the different files are there, and how you can access that, how you can make the link on that, how you can see like what are the links between these particular file. So okay, so you have that basic understanding about that stat system call. Okay, so I've created the variable over there. So this variable, why I need this variable, just to access that particular member of that structure. So what I will write here, I'll just declare some variable for returning ret stat argv of 1 and the address of v. Argv of 1 will be your that file name. I'll just write the error condition. If it fails, if it's a failure thing, if that RT is less than 0, I'll just write some error message over here, p error, and I will return from this. So now if it's successful, it will give me the size of that particular file of you, or if you want to see that inode number, what is that inode number of that particular file, you can see. v.st underscore size comma v.st underscore ino means inode number. Yeah, so this looks fine to me. So what I will do here, I'll just compile this. Okay, so this looks fine to me. Yep. ls hyphen li. Yep. Oops, I've not given that file name. Data. Okay, so now you can see here the size of that particular file is 14, and that inode number of that particular data file is 586792, which is this. This is your inode number, and this is the size of your particular data file. So in this, like you came to know that by using the stat system call, you can see like what are the size inode number, what is the block size, is this like what is that file information without opening that particular file. Okay, so now what are the important note you need to take here? In stat, when you create a soft link file, it will give you the information about the original file. Okay, so this is the information about the original file. So instead of stat, if we are using lstat, then it will give you the information about the link file. Suppose like in a soft link, like if we want to know about the particular file is a link file or not. So what we will do here, we will just write a program to check. Well, we will use lstat also. Are they a link file or not? So if that if there is a link file, if that particular file which we have given, it's a link file, which link is present in that file? Is it a hard link or a soft link? Okay, vi link dot c header dot h. I'm using that same argument because I need to run this program at runtime. Okay, this looks good. So The same thing I need to use here, but like I just need to mention both the files. So I have to create the two structure variable to see like what are the I just need to compare between the size of that particular files and the inode number, so we can compare the inode number, which will help us to check like it's a hard link or a soft link. In that hard link, if that inode number is same, then it will be like it's your hard link, or if your inode number will be different, then it will be a soft link. Link your file 1, your file 2, and I will return from here. So now I'll use the stat call. If it's less than 0, I'll just print the error message here about the stat, and I will return from here. Argv of 2, v1, great. So now what we will do, we will just compare the inode number. V dot st underscore ino and is double equals to v1 dot st underscore ino. This will give us the information about the destination file. Okay, so we have used this lstart system call. So after this, we need to compare the inode number about that link file. If both are equal, then it's a hard link. Else it's a soft link. Great. If nothing will be here, so we can mention no link. Okay. So this looks fine to me. We'll just execute. Great. Data and data 1. It's a hard link. Okay. So now we have created this file in file 1 and file 2. It's a soft link. So we can mention it here, file 1 and file 2. Soft link. Great. So in this way, you can see uh, what is the uh, what the files are hard link files, what are the files like soft link and all. So I just need to check, like I have never tried it before. I just need to check like it's possible or not. Vi test. Data test, no link. So now we have not created any link between that, so there is like a no link between this. Okay, so now you have that understanding of how we can see the links between the files. Okay, so now in actually in stat structure, if you can see here, yeah. Yeah. So in a stat structure, you have seen that st underscore mode, like I have shown you in, this one. In a man page, I have showed you this st underscore mode. This one. So this will give you the permissions, like what is the type of that file, and what is that what are the file permissions of that. So it will give you. So by using this st underscore mode, what we will do, we will just try to see that a particular file is a regular file or a directory file or a link file. Okay, so uh, actually, how we will come to know, like if in a like if a 15th bit is set and a rest of the bit is clear, then a particular file is a regular file in that particular mode. Like there'll be a mode and there'll be a number for that, and that your 15th bit will be set. Then you can come to know that it's a regular file. Or when it's a directory file, then your 14th bit will be set and rest of the bit is clear. Okay, so how we will do that? So we will just write a simple program, file info dot c hash include header dot h int main int argc character pointer argv structure stat variable. If argc is not equals to 2, I just need to print the message here, your file name, and I will return from here. Now if I need to see the relation, or I need to see what is that information about the particular file, I'll use the lstat p-error lstat return printf, we will just write that mode. If v.st underscore mode and with 1 left shifted by 15, logical and v.st underscore mode and with 1 left shifted by 13, if both are there, then the file is a link file. If v.st underscore mode and with 1 left shifted by 15, printf, file is a regular file. If v.st underscore mode and with 1 left shifted by 14, then file is a directory file. Yeah, so this looks good. So now we will just try it out. Great. File info. Okay. File info, your data. Okay. File 2. File 1 is a regular file. Okay, it's a regular file. Okay, so now mkdir test. Okay, sorry, mkdir testing ls. Great. File info testing, it's a directory file. So now it's a directory thing, so it's a directory file. Okay, so now for file info, file, okay, data 1, it's a regular file. File 2, it's a link file, but it's showing a regular file 2. I need to check. So it's a link file. So what you can do here, uh, now you have that information about that, which file is a link file, which one file is a regular file, which file is a directory file. So now there is another method of which you can use, you can use a macros like s underscore is link v dot st underscore mode. I think it's present in the man page, and I've showed you also. So if we will just compile this, yeah, file is a link file. So now I'll just show you to start. Yeah, see what is a symbolic link is link. Okay, so now you need to check with the other files also, like if you want to check it's a regular file, in that else if condition you need to pass this macro, or if it's a directory file you need to pass this macro. So you need to try it out by yourself. It's a very simple thing, you just need to change that. Please don't forget to like, share and subscribe, and we'll come up with the next session where we will discuss about the another concept of Linux system programming. Thank you so much.